Hi everyone! Today you're going to learn about motion graphs. So in your spiral notebook at the top of the page, write motion graphs. That's your title that you need to write down. So here's what we're going to be learning about. Motion means to move, so we could talk about how this basketball is moving, and we could do that with a motion graph. Here's why we do this. Describing the motion of an object can be hard to do with words. Graphs make motion easier to see and understand. So we're just going to create a picture in a graph that's going to show us the motion. So remember some things about motion. Motion is a change in the position measured by distance and time. So we've been talking about distance and time in our DIRT formula, how things move. Speed means the same thing as rate. So that tells us the rate, or how quickly an object is moving. So in your notebook, draw this graph, and we're going to talk about some of these pieces. So the x-axis is time, that's down here. The farther right you go, so the more I get over here, the longer the time has gone by. So this is the beginning here. So this is the beginning over here, and then as we go farther to the right, more time has gone by. The y-axis is the up and down one, and that shows us distance. So higher up that you go, the longer distance you've traveled. So if I start down here, I haven't gone very far, but the more and more I go up, that means the farther distance that I've gone. So we're going to draw some different lines on here. So now draw yourself a graph that looks like this, and this time we just have this horizontal line. Here's what that shows us. The time increases as we go left to right. So over here is the beginning, and here's the later time. Distance doesn't change though, bottom to top. So notice the distance at the beginning is the same as the distance at the end. We did not go up or down. It's a flat line. So that flat line means the distance is not changing over time. That means that the object is not moving. It is at rest. That means it's sitting still. It's not going anywhere. So whenever you see a horizontal line, the object is not moving. That's what that graph shows us. Here's another possibility. Now we're going to draw this graph, but now we're going to put a diagonal line there. So let's talk about what that means. The time is still increasing as we go from left to right. So we still have beginning here and over here. The distance actually increases. We start at the bottom of the graph and we go up. So we're increasing the distance that we've traveled. Notice that the time and the distance are increasing together. So here's the beginning, low time, low distance. Here's the end, longer time, longer distance. This means that the object is moving at a constant speed. So if you see a diagonal line, that would be like your bus driving to school and it only goes 40 miles an hour the whole way. Don't go 41, don't go 39, you only go 40 miles an hour. That is what that diagonal line would mean. Here's another diagonal line, but this one looks a little bit different. So draw the same graph again, put your original solid diagonal line, but now we have this extra dotted one. So time is still increasing as we go from left to right. And the distance is also increasing. Here's low distance, and as we go up, our distance gets higher. But notice that this dotted line is steeper than the solid line. So this one goes up faster than this one. So here's what that means. The dotted line is moving up the same distance. They start at the bottom and they end at the same distance at the top. So the distance that they're traveling is the same. But the dotted line is doing it quicker. It does it in less time. So this line shows us faster motion than this solid line. Okay? So this would be like if your bus suddenly speeds up and goes 50 miles an hour. And this other original line was your bus going 40 miles an hour. So this diagonal line is faster, and this diagonal line is slower. So a steeper line means it's traveling faster, but it's still a constant speed. You're only going maybe 50 miles an hour or 40 miles an hour. But that's not really how we drive, right? Sometimes we have to speed up and slow down. So this graph is going to show us something different. Time still increases, low time, later time, and distance is increasing, so we are moving here. But notice that it's not changing at a constant speed. This line is not perfectly straight like the other graphs. This is what's called accelerating. Accelerating means changing speeds and going faster as it moves. So this might be when you first get on your bus and it starts off pretty slow, right? Everybody sits down and the bus driver slowly goes faster and faster and faster and faster, right? And then you get driving and you go to your 40 miles an hour, okay? So anytime you see a curved line, that's accelerating. It starts off slow and then it goes faster and faster and faster. So let's summarize all of this. So take a second and draw this graph. I know it's a lot of pieces and a lot of lines. We're going to talk about what they all mean. Okay, so the first thing we're going to talk about is the time down here. Remember, the x-axis on the bottom is always the amount of time. The y-axis over here is always the distance. Okay, that part will never change in a motion graph. Now, let's talk about the part of the graph where you just see this flat, straight line. So that was the first one that we talked about, where the object is not moving. So for this part of the graph, whatever the object was doing before, it has stopped. It is at rest. Now, if I look at this diagonal line right here, that's where the object is moving, and it's doing so at a constant speed. So this over here corresponds to that part of the graph right there. So what this tells me is that if I start here, the object was going 30 miles an hour, but then maybe you were on your bus and it had to stop at a stoplight. Then you would be stationary and sitting there while you're waiting for that light to change. So you were going, then you stopped, and now you have to wait for that line to change. So that's what those two pieces show us. Now if I looked at this steeper diagonal line, maybe your friend is on a different bus. Remember, a steeper line means that they're going faster. So maybe your friend's bus is going 50 miles an hour. It's going way faster than your original bus over here. We also have this curved line where the bus is accelerating. So it starts off really, really slow, and then it slowly builds up and goes faster, faster, faster as it drives. Now this last one is where the line goes down, and we didn't really talk about what that means. Whenever you see a downward sloping line, the object is returning to its starting point. So this could be you leave your house and you drive at a constant speed, and then you pull over because you realized, oh no, I left my phone at home. So if your line was going back down, this would show us that you were going back to your original starting point. So don't get worried by that. It just means you're turning around and going home. All right, that's everything you need to know about motion graphs.